Lalagyan ko yun, sir, ng mga drawing. Kaya hindi ko pa ina-upload. Ang highlight nun, sir, yung yung pinangalanan mo lahat. Lahat ng parts.
Kasi no? Kasi hindi ito ganda yun.
Master ko kasi pag nag-graduate,
Ay, sa pagkabit ng ano? Master. Extension. Ano ba yan?
Ayun o, yung gamit yung rubber.
Ito pala.
Rubber pallet.
Okay. Hindi, malabas na sa
Oh.
Hindi pa.
Maluwag talaga yun.
Yan.
Sir, pala na. Nandyan na.
Demonstration and discussion of the operation of the Union Drive and the transmission.
Ah, sige.
Information is
Okay
visual.
lang.
Sure yun. Sure, nasa cellphone. Kasi nga meron ginagawa rin eh.
Although this particular one was in 1992.
Monday.
Hindi ka nasabi ng sirisado ka dyan. Malaking kita dyan.
Hindi, sir.
We could be looking at
I-encourage yung mga taga dun sa amin na mag-enroll. Diba libre naman sa nag
from just about any
Libre sa ano. Hindi ka na nabota. Pero hindi lahat libre.
Hindi na lahat.
the theory
Hindi
of
na lahat.
Scholar, pag scholar, libre lahat yan. Pero pag hindi scholar, meron mga binabayaran.
Yung sa akin, lahat wala. Dito naman yun.
Ano
over
ba?
here, we have input shaft.
Tatlo.
Ha?
Tatlo kinuha ko
Flush
dito.
gas winding
Computer,
connector.
automotive, sa
Kaya
kanya.
nga mga scholar yun.
That's going to
Ang
reduce.
scholar pala kami nun.
Oo.
Underneath here, we have
Kaya kayo naman.
Kasi yung solo parent ako, di ba? Pag solo
since it
parent
is
ata,
here right directly to the input shaft.
ginamit ko lang yung solo
It's
parent
going to
ID
turn
ko.
every time the input shaft turns.
Ayun,
Notice the output shaft back here that goes to the rear wheels isn't turning
Sige,
at
buko
all.
na ako. Meron ako yung
sige, sir.
When I turn the input shaft, and that's because we are neutral. Now, if I zoom in a little bit here, you can see that we have 4 different shift shafts here, and the shift mechanism that sticks through the floorboard is going to come down and connect and operate these shift shafts. So the top shift shaft is the 3/4 shift shaft. It connects to the 3/4 shift fork right here to get us 4th gear or neutral or 3rd gear. The next one down is the 1/2 shift shaft, and it connects to the 1/2 shift fork, so we can have 2nd gear or 1st gear right here. We have the reverse shift shaft, so it connects to a shift fork down below that moves the reverse idler into contact with the counter gear and drives the output shaft backwards. And then we have a 5th gear shift shaft for 5th gear right back here in the back of the transmission. This could be a 4-speed if we didn't have the 5th gear shift shaft. This could be a 6-speed. If in the back of the transmission we have 2 gears instead of just 1. 7-speed, 8-speed, doesn't matter. They all have shift forks, some sort of shift shaft mechanism, and they also have an input shaft, at least 1 counter shaft. Some of the heavier trucks have 2 counter shafts, and then an output shaft. I'm going to rotate this transmission around and pull it back out. Let's just look at the front here for a moment. You can see the input shaft. Here we have some splines. We have a little machined area right there. Those splines are where our clutch disc come in and damper springs. And so it's going to slide onto those splines. And when the clutch is applied, it will turn the input shaft. Here on this machine area, we have a pilot bearing that's going to fit right here. And that fits into the back of the engine's connection. And if we have to change the clutch and the transmission, you should install them. They're also. We continue rotating the transmission around to where we've got the back of the transmission, the output shaft over here, is the front with the clutch disc and the input shaft here. Now, if we zoom in, we can look at the synchronizer assemblies. Because manual transmissions, in order to shift from one gear to the next, all of these gears are spinning at different speeds. So in order to complete the shift from 1st gear to 2nd, 2nd to 3rd, 4th, and so on, we have to synchronize the speed of those gears, which means the speed of the input shaft and whatever gears that happen to be turning needs to be synchronized to the speed of the output shaft. So that's done with synchronizer assemblies. And so right here is our 3/4 shift fork. Here's our 1/2 shift fork back here. And we have a shift sleeve. And then right down in here you can see this little brass locker ring, sometimes it's called synchronizer ring. But the synchronizer typically is the brass ring. It actually has a tapered edge on the inside. In other words, it's not perpendicular, it's not an angle like this. That's going to ride up against the gear that also has a tapered cone. And with the synchronizer sleeve is going to push that tapered cone of the brass ring, the synchronizer, up into the cone of the gear itself. Shiny surface right here. So you've got a tapered area here in the synchronizer, you've got a tapered area here on the gear itself. And the synchronizer will be turning the speed of the output shaft. The gear will be turning the speed of the input shaft. When you step on your clutch, delivering power from the engine, you want to synchronize the speed of those two to make them be the same. So this synchronizer sleeve right here will push onto the brass synchronizer ring and shove it onto the gear that's turning a different speed. Then the synchronizer go and it'll either slow it down or speed it up to where it will match the speed of the input shaft to the output shaft. And so let me give you a little better demonstration, a different demonstration of that. Let me zoom out just a little bit. I'm going to grab the output shaft right here, and I'm going to grab the input shaft for the clutch connects. And notice when I spin the output shaft, and let me zoom in so you can see what's moving here. I'm just going to spin the output shaft. The input shaft's not going to move. Notice the only thing spinning is the 1-2 synchronizer sleeve and the 3-4 synchronizer sleeve. The 1-2 synchronizer sleeve also happens to be the reverse.
Matapos ang 92 centavos na decrease ng July ako, nag-increase na 39 centavos ngayong September. 9 pesos and 94 centavos na kilowatt-hour na yun. Tulong dito ng pagkaas ng
Ay, lang kilala ko din.
Here, it's like an idler or two down here to those two synchronizer sleeves, steady set speed. Notice fifth gear does. The back here also a fifth gear synchronizer sleeve. Notice this back here. They all spin with the output shaft. Now I'm going to hold the output shaft still and turn the input shaft. Notice now everything else in the transmission rotates except for the synchronizer sleeves. So to shift from one gear to the other, somehow we have to connect those two shafts together. And that's again, it's done with synchronizers. So zoom out just a little bit here. And I'm just going to take you through the different gear ratios of the transmission and show you the shift sleeves and synchronizers movement. So on the output shaft here, I have a yellow label that says output shaft. On the input shaft here, I have a yellow label that reads input shaft. And so I'm going to shift this into first gear. Typically, when you're shifting first gear, the engine is running typically, but if the clutch pedal is pressed, that releases the clutch disc, just as it hold to the engine's crankshaft. And so the input shaft will stop. So here's a 1-2 synchronizer right here. The shift fork comes and grabs the synchronizer. We're just going to push it back to the first gear position. Maybe. Okay, just shifted into first gear by moving the synchronizer sleeve back with the shift forward. I've got the input shaft label, the output shaft label. This particular transmission is showing gear ratio of 3.83. So that means I should turn the engine with the clutch input shaft 3.8 times. So there's 1, 2, 3, and 3.8 times to get 1 the output shaft right here. So that is our first gear. All right, now, to go to second gear, we need to move the synchronizer sleeve and disconnect the synchronizer hub from the first speed gear and move it over here and connect it to the second speed gear. But while it's shifted into the first speed gear, let me zoom in a little bit more. You can see a little better detail. You've got the synchronizer sleeve, the synchronizer hub right below it, the brass locker right here, and the gear, second speed gear itself. So the brass blocker ring, just like the piece I showed you, the tapered cup. This gear right here is going to have, this isn't the exact gear, but it's just like it. It's going to have this tapered edge. And so when we shift into second gear, this sleeve is going to come over, push against the brass blocker ring, and try to lock it to the same speed as the synchronizer sleeve, which is connected to the output shaft, which with your foot on the clutch pedal, because remember you have to have your foot on the clutch to shift, that should allow the two shafts, the input shaft and the output shaft, to connect together and shift into second gear. So we will pull that forward into second gear. There we go. Now we're in second gear. The output shaft is connected to the input shaft, but we need to line up our stickers here. Here's our output shaft label. So you can see it. Here's our output shaft label here. Here's our input shaft. With our gear, our shifter sleeve moved into the second gear position. We should have a gear ratio to pretty much 2 to 1, 2.062 to 1. So here we go. There's one turn of the input, 2 turns of the input, tiny bit more, 2.06 turns to 1. And all we did was connect the output shaft through our shift sleeve and hub to the second speed gear through the synchronizer wrench. Okay, now we're going to shift out of second gear, and here's our 3/4 shift sleeve and shift forward. And so we're going to move to the third gear position. So shift that to the third gear. There we go. Move it back to the third gear position. And now our gear ratio should be over 1.4. Here's one turn of the input, and about 15 one turn of the output. So 1.4 turns of the output, which goes to the rear drive shaft or to the pedal. Notice here that we're 3/4. In the second 4-speed gear. These synchronizers, by the way, the material, brass,
Bakit? Kala ko si wala ka tayo. Hindi meron. Ito pa ako. Matubos na to eh.
does wear out over time.
Sige, ano naman na, kuling man na.
As you can see in this video, those grooves wear out. And it gets,
Oo, wala.
synchronizer has a hard time synchronizing the speed
Ito na.
of the input shaft to the output.
Buti meron pa.
Para talaga tayo.
So grind while you step on the collection plate.
Kaya ulit tayo.
So this is simple.
Ha?
Ito lang yun.
Meron ko kaya kanina ang pangalaman.
So,
Just take a few of these.
Gaga. Kasi nakaabot ka pa. Yung isa.
Si ano? Ito yung Arsenio, si ano to eh. Yung
Let's allow
Kukulot.
pala Arsenio.
synchronize with block array.
Alam ko walo tayo kahapon eh.
Oo, wala nga tayo.
Sino ba isa?
That gap is going to be a
Nega. Oo. Pakiro dan. Oh, si G.
Si Russell yung pumasok eh. Pumasok siya si Dexter.
a lot of vehicle manufacturers
Gino.
specification for that.
Gino. Pumasok pa ako si Gino.
Ayun si Gino.
Ano?
The grooves are not aligned. So the thing just spreads.
Buti meron pa Gino na isa.
Pushing and synchronizing the speed of the gears. So now we're at third gear. We want to move to fourth gear. So fourth gear is this gear right here. Let me zoom out just a little bit to show you the physical size of the gears. First gear is this giant gear right back here. And we have that gear ratio of 3.81. Second gear is this gear, it's a little bit smaller, with the gear ratio of 2.062. Third gear right here, a little smaller than second gear, 1.436. Fourth gear on this particular transmission is a 1-to-1 gear. So what's going to happen here is when we move the gear selector into fourth gear, right there, reverse shift the speed up and in, we are going to have one turn of the input shaft. So here's our label, so you can see. Here's our input shaft label, just starting to show right here. Here's our output shaft label in full view. So notice now we have one turn in equals one turn out. It's a 1-to-1 gear ratio. Also pop up direct drive. Some transmissions it's fourth gear, some it's fifth, some it's third. It just depends. Some of them don't even have a direct drive. It's just something a little higher than 1-to-1 or lower than a 1-to-1 gear ratio. So that is direct drive. But this is a 5-speed transmission that has overdrive also. So if we shift back into neutral, shifter here, and we are in neutral, there's no connection to the output shaft. Now on the back over here, we've got a fifth gear with its own brass block rings and shifter, shift fork. And if we move it into the fifth gear position, there we go. Now we are in overdrive, where we should turn the input shaft just 8/10 of a turn to get one turn the output shaft. So here's our label back here. And I'm going to just hang on to the clutch housing here. Notice as I turn the clutch distance. So we're going to get a full turn of the output shaft before I can bring the fingers all the way back around to one full turn here. So we are in overdrive. We got a full turn of the output shaft, but I'm still 2/10 of a turn away from the full turn of the input shaft. That's overdrive, which gets us better fuel economy. On a 6-speed transmission, some 6-speeds, fifth gear is direct drive, the 1-to-1 gear ratio. But anymore, because of the fuel economy regulations, fifth gear, like on this transmission, is overdrive. And then sixth gear is a double overdrive. So you may have, instead of 0.8 gear ratio that we have here in fifth gear, you might have a 0.6, or even, I've seen as low as a 0.5 gear ratio, like on the Viper or the Corvette, made for really high vehicle speeds. It also gets you some pretty decent fuel. But that gives us overdraft. So now take it out of the fifth gear, back to neutral. So here we are in neutral again. Now we want to go to reverse. Notice right here in the front, we've got a reverse idler here. It's not being in. So when we move to reverse, we're going to move this idler here over. It's going to mesh with the 1, 2 synchronizer sleeve and the camera shaft at the same time. There we go. So we move that over. Reverse does not have a glass blocker. There's no synchronization of reverse. So for reverse, you need to be stopped to shift into reverse or it will break. So now, when we turn the input shaft clockwise from the front here, notice the output shaft is turning the opposite direction. So let's see what the true issue is. These manual transmissions have bearings, they have some in-play checks, they're selecting shims, designed to ready for position, the proper lubrication type, and level is important. All manual transmissions, direct transaxles, and manual transaxles, and special synthetic gear lube now for improved fuel. So, this is a 1992 rear-wheel drive transmission. If you open the 2012 rear-wheel drive transmission, you will see these same cars. About the only difference you see pretty much anymore is the 1-2 synchronizer that you stick down just a single line, and 1-2 synchronizer like this will have a dual cone, a triple cone synchronizer, which allows for high-speed performance type shifts from first to second gear, or from third back down into second. But on every single shift, you have to go to neutral between the shifts. Looking at a 2010 rear-wheel drive transmission, almost the exact same model, which just like this, except this housing instead of being cast iron is aluminum. So they can make it to the same fuel. This has been a demonstration of the operation of a rear-wheel drive manual transaxle, the transmission, so the rear-wheel drive transaxle, so the front-wheel drive transaxle operates just like it, except instead of having the output shaft sticking straight out the back, think about a transaxle as this output shaft being cut off, turn back around and head it around the front to where they can drive the final drive gear.
Ano yung mga function ng bawat gear?
Same gears, same types of synchronizers, same precautions during service. The most difficult thing with transmissions is it requires a lot of hydraulic press. You've got to be real careful as you're pressing these gears on and off that you don't break the gears or break any of the parts.
Mga function bawat isang gear yan. Sa laptop ko maganda. Marami sa ano. automatic transmission.
Today, I'm excited because we are going to go through a performance motor from the rear of a Tesla Model S P1 from the model year 2016. Now, our school here, our automotive program, actually has a 2018 P100, but they wouldn't let me disassemble that. So I searched all over, tried to find it. A rear drive unit, which is the motor, gearbox, inverter, everything all together. And as you can see here in the photo, I finally found one that we could afford. It is a burned up one. Is it from a car fire? And I thought, well, how hard can it be to just clean all that smoke and soot off of there? And I'll tell you, it was a mistake. From the burned vehicle. I spent way too much time trying to clean this thing up. And of course, it has some damage to the electronics, but I wasn't so concerned about that as I was the gears and some of the neat things that I like to look at in my business. So let's get started looking at the pieces of the rear motor on the Tesla Model S. I've got the housing right here of the gearbox, one half of the housing. The other half of the housing is on the other side. Stator housing back here on the other side of the bench. But inside of this housing, right here, we have places for 3 bearings to sit. We have places for the 3-phase cables from the stator to come through. And then we have 2 coolant passages that we'll look at a little bit later. And as a matter of fact, I want to divide this video into 4 separate sections. So section 1 that we're doing right now is the gears and the motor. Section 2 will be some unique things about these bearings. Pretty incredible. Section 3 will be on lubrication. These bearings require some special lube in order to withstand the high RPM that they operate or can operate at. And then the 4th section will be on the cooling system to keep that oil cool so that the bearings will continue to survive along with the rotor and stator to keep everything cool. As with any other transaxle transmission, we have to have a final drive gear, differential unit. So we have a differential case from the Model S, and the very first time I split the case and got this thing apart and saw this gear standing sideways in this gear reduction unit. Some people call it a transmission. It's a gear reduction unit. It does not shift. It's a 1-speed gear reduction unit. But I started laughing because this has the biggest bearings I've ever seen on a differential transaction style with the vehicle cut gears. So this green gear is monstrous. It's a 213 millimeter diameter gear and it's 50 millimeters thick. That's and it's held to the differential case with 16 bolts, which is pretty unusual. There are other cars, that front-wheel drive cars, vans and so on, that also have 16 bolts. They're not 50 millimeters thick either. But the thing that really made me laugh was this bearing. This bearing is 110 millimeters in width, and it's just a monster. And so we'll take a look at some of the specifications on these bearings here. But the differentials are different. This thing operates just like any other open differential. And the maximum, or see this differential has 78 teeth on it. And the maximum RPM that this differential rotates at the top speed of this 2016 P90 at 155 miles an hour.
Kasi 38 na
This is only spinning at 1841 RPM. So this is the slowest spinning part in all of this gear reduction. So by comparison, I've disassembled two other EV, electric vehicle gear reducers, and I just want to show you how they compare to the Tesla performance model. Now, I know this is comparing apples and oranges because this is a performance model and these other two are not. But this next one that I have right here is from a Chevrolet Bolt EV. And it has, instead of 16 bolts holding the ring gear on, it has 12. It has some decent sized bearings, but they're smaller than the Tesla one. And look at the height difference in the ring gear. It's only 34 millimeters thick rather than 50 millimeters thick. And then if you bring in the little Nissan Leaf, it has 6 bolts holding the ring gear on, and it only has a 32 millimeter wide ring gear right there. So I know these vehicles were not made for performance. I'm not trying to make fun of them or downplay them. I'm just showing you how big this Tesla performance differential is compared to other EVs on the market. And as a matter of fact, any other front-wheel drive or rear-wheel drive transaxle that's out there. Okay, here's a few other photos showing the differences in the physical size of these differentials and ring gears. Now, let's put this Model S differential into the gear reduction unit housing. With these big ball bearings, they just slide down into the housing, but it's a lot harder to do that. So once that's fully seated, we can move on to the next gear, which is our counter shaft. And it has 2 gears on it. It has the pinion gear that drives this ring gear here. And this pinion gear has 25 teeth. And the ring gear has 78. And if you take 78 teeth on the ring gear divided by the 25 teeth on the counter gear, then we get a gear ratio of 3.12 between these 2 gears. And then it also has the same 78 teeth that the ring gear of the differential has, except they're much smaller. And they are driven by 25 teeth that hooks to the motor shaft. So let me set this counter gear down in now. Put the tail sticker off. Just like that. Sticker on the top. Sticker on the bottom. All right, at the top speed of the vehicle at 155 miles an hour or 250 kilometers per hour, this shaft spins at 5,743 RPM, which is 3.12 times faster than the differential. By the way, the differential turns the same speed as your rear tires. So on our P100D and on the P90Ds that I've researched, the rear tires are a little bit taller than the front tires. And so it's just the rear tires that this differential will spin the same speed. Okay, so the next shaft that we have, I don't know its exact name, I just call it the motor shaft, because this shaft connects directly to the motor. And it has 25 teeth on it that drive the 78 teeth of the counter drive gear. So we get another 3.12 gear reduction. So I'm going to take this shaft, the motor shaft, and put it down in its bearing, just like that. Now, these bearings on the motor shaft have to handle the rotational speed of that motor shaft and of the motor itself. Because they're all connected together. Take a look at the motor here in just a moment. But I did the math for the tire size. They came on the rear of that 2016 P90. And at the 250 kilometers per hour or 155 miles per hour, this shaft in these bearings is spinning at 17,919 RPM. so almost 18,000 RPM. The motor is spinning if you run your vehicle at top speed, which of course you better be on the track somewhere rather than breaking the legal speed limit. But those are some incredible speeds. Now, of course, most people will never get anywhere near those speeds. Those speeds require special lubrication, pumping up the special oil through these bearings to keep the cool tires and a special cooling system to keep that oil. So anyway, now we've got, like, tip it up on its side here. We just have a motor shaft, spinning the counter, drive gear, spinning, driven gear, spinning the alloy. And that gives us an overall gear reduction of 3.1 gear here, multiplied by 3.12 from this gear to 5, which gives us an overall So 9.734 rotations of the rotation of the tire.
Discard yata yung ano.
Ay, wala. May nag-like isa.
Naglalay. Baka si crown nila niya.
Oo nga, sabi. Pero nasa dagat si Crowley ngayon.
This motor weighs
Eh, yung motor niyo,
1.5 kilograms,
nakakamatay yan pag nakuryente kasi.
which is more than I'm able to just toss around. And so I'm going to set it in some V-bolts to show you a few things about this road. Okay, first thing is the PDD. The version of this rear drive unit was only
Yung stator niya, yan yung stator. Yan, rotor.
part number of this rear drive unit in
Sinalpak mo yung
and the part number of the rear drive unit in our P100 so there's been one revision somewhere for the increased performance of the maybe some differences in bearings. So let's take a look at this. This is a three-phase, four-pole AC induction. This is an induction. It is rated at 370 kilowatts.
Tingnan mo, lalo kalakas yan, no?
Unless you put it in ludicrous mode.
Kaya kang patayin yan. Nakuryente ka. 391 kilowatts or 532.
Pound-feet of torque or 636 Newton meters.
Yan ang mga tinatawag na ano.
The time machine on the internet.
Hybrid car. Yan yung mga hybrid. Meron ng Toyota niya yung ano, yung Camry.
As I mentioned before, we have a gear reduction from the motor to the tires of 9.734. This one's correct, 9.734. The indication of this road is 9.7 tires. as I said before, also this rotates to 17,000 at 250 kilometers per hour. Now, when I first found it, it's up 18,000 RPM. One of the kind of bearings that is used. And because the later Toyota Priuses have motors that spend 17,000 at their cost. And this goes up to 155. And the new models that was just announced was up to 200 meters. So I'm really curious to see what they have for bearings. So there's some very unique things about these bearings. There were some bearing failures early on in the models, and they switched to what everybody calls a ceramic bearing. But it's really not ceramic, it's called silicon pipe, according to SKF's website. Now, SKF is the bearing manufacturer for the majority of the bearings in this region. These bearings, the ball bearing portion of the bearings are made of non-conducting material. Silver, ball bearing, see it in the other bearing, kind of dark color, that is that silicon nitride. And both front and rear bearings on this motor are non-conducting, so there's no electrical current running through there, no arcing that can occur in damage from what I read. The balls are 60% lighter than the previous one, which means they have less mass and can spin higher RPM. They don't expand like steel bearings, so they can run at higher RPM. It takes a special lubricant, there's a special seal that goes on the outside. So the seal is this dark seal, and this is the lubricant that's on the back side. But normally that would be right here, covering up those ceramic balls, so you couldn't see them, but I wanted to see them. So, very interesting bearings. These bearings have no external lubrication fed to them. They have no external cooling system fed to them. And this rotor does not spin in oil transmission fluid cooling. It's a dry spin inside the seal. Okay, as you can see, the copper filler here on the rotor does have a copper plate. You can see some factors on either end. They appear to be just straight through without being tilted or twisted. On the front of the motor, we have a speed sensor. There's two really. On an induction motor, we just need to monitor the rotational speed of the induction motor, not its actual relative. So we just need to know the speed. Both bearings, this one here and then the back, same part number from SKF. I'm trying to find this bearing. Let's take this rotor and put it into okay, that's what I chose putting that in there. But as you can see, it just connects directly to that upper shaft. And as it rotates, with one rotation of the unit itself that hooks to our CV shafts, CV half shafts, Here's the end of the CD half shaft, the tripod with the tripod joint. It just slides right over the side here. And there's another one that comes in from the other side. So as you electric motor turns, so the CD half shafts. So this is pretty basic stuff. As far as the gear train is concerned, there's nothing magical about this other than it's just big, heavy duty. But as I mentioned before, these bearings to withstand the high RPM that they have to at the maximum vehicle speed and even production have to be some special bearings. Now I mentioned for the Prius, MG1 and MG2, the latest generation 2016 can span clear up to 17,000. They're these little tiny lightweight motors. These bearings control the big heavy road and handle a whole bunch of torque at the same time. So an interesting thing is that is when you support these two little silicon nitride deep ball bearings, and it just spins inside of the stator assembly back here. Let's take a look at the stator for a moment. We have the stator housing cover that fits right here. And we have a bearing, a non-locating bearing, so it moves just slightly as the rotor gets up the first thing. And then the locating bearing is all the way in the bottom of the board here. And the locating bearing is the one that holds solid, that doesn't move with expansion and contraction of the metals as they get this is a 67 stator assembly, 67. I'm not sure how it holds, I'm not sure how it's wound. But if you really know, I couldn't find anything. The motor is a 4-point. This stands with the housing that it's in weighs 125 pounds or 56.7 kilograms. This thing is heavy. Very heavy. Especially when it's this is driven off of that 72 which means it's a little over 3 times. So the linear speed is this way, spins 3 times faster. And this door has a jump, and it's not to be regarded as big. It's to keep those variables. Housing for the bearing feeds and through to the front, and that's on the motor shaft. And this tube here sprays across to the other bearing. So our motor shaft has 2 different bearings on it. And then the centerpiece right here sprays on the motor bearing. Because this is the gear that's going to have torque big deal about it is the roller of this spins on two lightweight, non-cooled ceramic silicon nitride bearings. But it turns the motor shaft. The motor shaft has to have all the thrust torque from rotating that kind of drop gear, calibrated gear, gear drive. So with, what did we say, 600 meters maximum? 460 meters. That's a lot of torque. These bearings they have to be very strong to be able to handle that, and they require a lot of lubrication. This pump, as I mentioned, has one job, and that's to keep those two bearings on the motor shaft. Also to spray oil on the motor shaft where the emissions will be counter-driven. So that's pretty incredible. When I first opened this up and I saw that oil, I thought, it's lubricating all these bearings and whatever else. No, it's just the motor shaft, bearings and gear. So when I looked up the part numbers for the two bearings on that motor shaft, I just wanted to see what the specifications were on bearings. Were these also special silicon nitride bearing or not? It's a special high quality bearing. I think they call it their Explorer series bearing. But an interesting thing in the table is that one of these, there's 2 speed bearings for each bearing. There's one called a reference speed, which one of them is 20,000 RPM as a day, and then there's a reference speed, which is a mechanical reference speed. Without doing anything extra, there's no external lubrication or anything. 13,000 and 11,000. But then I saw a little note that said you could run bearings higher than those speeds if you do some special things. So the catalog says it is possible to operate a bearing at speeds above its reference speed, which adjusts the speed even its limits. So we run these bearings above the limits. So before doing so, make sure you look whatever further measures may be required, such as the use of special cage execution for considerably precision. The bearing the effects of increased speed considerably. And this leads up to, you can see what increase in bearing temperature by additional this pump here running fluid gives them the compensated rate reduction of bearing clearance resulting from increased bearing temperature. The ball should expand and so the bearings that are in these are special high clearance bearings. Clearance that's above in regard to the testimony, ensure that the lubricant and lubrication level is compatible with the higher operating temperature of the cage execution. So as I mentioned, that was a special, this is just regular automatic transmission. This to stick with the testing level. And then check that the lubrication interval is still acceptable, particularly for grease lubricated bearings or lubrication also using oil lubrication. So they've done what they need to do to run these bearings at higher speeds. Of course, you have to be running at top speed all day long every day. And so it's probably not a huge concern for it's very interesting. The things that they've done is good. Right, now, as far as lubrication, you mentioned it takes a special lubrication. I don't know what it is, I don't know where to go. So if you don't know where to go, just hire it, that's all, that's great. I don't believe that at all. Share the comments below on what it is. Right now, as far as draining the oil from the gearbox, right here on the bottom of the gearbox, right here on the side, there's an oil fill and oil level check. But as the service that I've accessed is less than. All right, this house, let's take a look at a few other things while we're there. There's a vent here on the gearbox side, and then there's a separate vent for the inverter power electronics. I mentioned that this drug unit is out of the car, burned down, but I was able to clean up the tag enough that we can read the words. That's just like the tag in P100D. What else is stored up here in the part number description. So this is the stored version of the model. I mentioned that vent for the gearbox. This drive unit has 3 different areas that are sealed off from each other. We have everything that's in the gearbox that we've looked at, and it has the special gear oil in it as we discussed. But that needs to be totally sealed from getting into the inverter area where the electronics are. It needs to be fully sealed from the antifreeze cooling passages that run through this drive unit as well, and it needs to be sealed from getting in where the rotor is, because that's the drive area. So there's special seals and O-rings all over the place to keep those sealed. And so, if you're planning on taking one of these apart and putting it back there, especially any type of fluid in the inverter area is going to cause some major problems. Okay, let's look at how this drive unit is cooled. If you look at the back cover of the stainless unit, if you look at this photo of our here on boys, you can see that has an inlet hose coming from the front of the vehicle. I haven't traced where it comes from, or where it goes, but in the front of the vehicle, I'm sure it ends up at the chiller eventually through some sort of switching valve and a radiator to get cooled down. And then as it comes back, we have this piece right here. And that inlet hose connects right here. Since this is out of a burned up vehicle, the plastic inlet fitting melted off. But this is where the coolant would come into this drive unit. Now, as it comes into the drive unit, it goes 2 ways. One way is that it goes up, and then all the way down the middle of this hollow shaft right here. And this hollow shaft, with the seal, sticks down inside of this induction motor. Now, an induction motor runs harder than the internal permanent magnet motors that a lot of other vehicle manufacturers use. So it runs coolant down through the center of the rotor where it's blocked off at the bottom, and then it has to come back up around the outside of this tube, where it goes through this seal, and then it goes up and out the top of that here. So that's one direction the coolant goes from that fitting. The other direction is it just goes down and through this fitting right here connects this passage, which on the side is just a straight passage. So you see.
Tapos ito palinis talaga po yan.
Means right here into the bottom. So it comes in the bottom, goes up and around, and then if we switch this around here, you can see that it comes out. Whereas then, we have a gearbox right here, and down to feed and cool the inverter IGBTs that run the three-phase power to the stator assembly. We'll take a look at those here in just a moment. The next part of the cooling system is that if we put this cover back on here, and we get our inlet and our rotor cooler. Oh, by the way, this other hole right here is for the speed sensor for that tube wheel on the top of the rotor. But what I want you to see here is that as the coolant comes up through that hole, there's a pipe. This pipe goes into that outlet, and it comes up front here to a hole in the gearbox, where it goes through right here and goes into the other half of the gearbox. So now we're ready to look at the cooling passages in the other half of the gearbox. Oh, by the way, this wire right here coming out by our three-phase connectors for the stator has 4 wires, 2 blue and 2 green. I believe these are stator temperature sensors. There's probably an inlet and an outlet temperature, I believe. Okay, that pipe with that little hole that went through the other half of the gearbox lines up with this hole right here. And it comes through this coolant passage. Got labeled coolant flow going down. Got the coolant flow coming from the stator going through. And now let's look at the other side. Okay, coolant from the stator comes in, goes through this passage right here, and it ends up on the inside of these 3 sets of holes right here. So these 3 inside holes is where the coolant from the stator comes. Now notice there's a temperature sensor right here measuring the temperature of the coolant coming from the stator. There's 3 sets of these holes because they cool 3 sets of IGBTs and capacitors of electronics that are all here to control the current and the voltage at the 3-phase connections at the stator assembly itself. Now I've taken this cooling passage apart on this IGBT module, and as you can see, there's all kinds of little buttons, whatever you want to call them, I don't know how to describe them, sticking up there, heat sinks, to transfer heat from the 32 IGBTs that are on the other side here. You can see this definitely got burned up into the coolant as it goes through. Now, if we compare this housing with the two fittings here. This housing is going to pull right there. And so if the coolant comes in on the inside, then that's this hole right here. So that is going to come in. You go up this channel right here, spread out to these four holes and come up across all of those little sections, and then go back in and come out on this hole right here, which is the outside hole on these four or three cooling passages. And once it goes in to those outer ones, you can see that, well, you can see a cast channel where the coolant comes in from the stator, then it cools all three sets of IGBT modules, and then it goes out through this passage right here. And there's an outlet coolant temperature sensor right here also. And then it goes over, and there's a hole right here. And notice there's a whole bunch more heat sink pins right here on the gearbox. And that little tiny hole that came from that pipe back here on the stator housing feeds coolant into this hole, and then the coolant runs through all these little pins where there's a heat exchange between the hot transmission oil and the coolant. So it transfers heat into the coolant. And there's a plate that fits right here that bolts down. You can see in this photo here from the one in our car, what it looks like in the car. And then it has this fitting right here that bolts right there. That is the outlet to go back inside of the back seat to a water pump, where it's through the onboard charging pump, and then back out to go back to the front of the car. So we've got a cooling system for the stator.